Yes, students, this is Michael. This second video on poker will cover writing the functions for each kind of hand our poker program needs to determine based on an integer array of 5 numbers. So we'll be writing the high card function, the pair, 2 pair, 3 of a kind, full house, straight, and 4 of a kind. But before we start diving into the functions, the function writing, I want to just give a sample output of what our program will look like by the end of this video. So I will just run a test quick. Okay. So we can see that we're prompted to enter 5 numeric cards using values 2 through 9. And so what I'll do first is I'm going to enter, for example, let's test the high card. So I'm going to just enter a number of random values, and the highest value will be 9 here. So it responds that our highest card is 9. That's great. So I can run the program again, and let's, for example, test a full house, which consists of a pair of 2 cards and then a 3 of a kind. So I'll do that first. So we'll put a pair first, and then let's do a 3 of a kind of 5s, and we expect to receive a full house. So that's basically what our program is going to look like. It will test every single kind of function, and note that in our PokerHand test.cpp file, the one that runs the main function, we're testing each function in a series of conditional statements, and we want to test them in a certain priority where we're testing 4 of a kind first, then full house, then straight, then 3 of a kind. The order here is important because, for example, if we test a 3 of a kind before 4 of a kind, it will return that our hand was a 3 of a kind. Because if you consider, if you have 4 4s, for example, it is also true that you have 3 4s. It is also true that you have 2 4s. It's also true that you have a pair of 4s. So you want to test it in a certain priority that's specified here. So now let's jump to the file that the skeleton code that you were provided with for this assignment. So if you've completed part 1 of the poker video, you should have set up 3 separate files. You have your PokerHand.h, your interface file that declares all the functions you're going to use in poker. You'll have your PokerHand.cpp file, which is what we're going to work on in this video. That basically just includes the definitions for each function. And then you have your PokerHand.test file. So keep in mind, there are a few changes I've made to the PokerHand.test file. We're going to need to include the interface file. So you need to include PokerHand.h. And also make sure that we're just passing in our integer array of cards as cards, the variable name, not cards followed by brackets. We just want it to be cards, the variable name. Okay, so let's first get started on writing the high card function. So if we go to the project handout for poker and we scroll down to part 3, section part 3, and the goal of the high card function is basically to look through every element of the integer array, and we want to keep track of the largest value. So we're going to use a for loop like this to iterate through each element of the card array. And what we're going to do is we're initially going to set this integer high card value to be the first element. So at the beginning, 4 is the highest number in the card array. Then our for loop will jump to the next element in the card array, which is 2. And we're going to use an if statement to compare the card element at this index against the high card, which was originally set to 4. So it's going to ask, is 2 greater than high card? So we want to put high card in here. So if 2 is larger than 4, we'll set high card to equal 2. But 2 is not larger than 4. So this if statement is false, and what we'll do is we'll just update our I variable, which will jump to 6. And now we'll compare cards at the second index. So number 6, is number 6 larger than 4? Yes, it is. So we'll now set high card equal to 6, which is cards at index of 2. And then we can imagine we just keep on doing this. Is 9 larger than the high card? Yes, 9 is larger than 6. So we'll set high card to 9. And then 5 is not larger than 9. So we'll eventually want to return high card after we iterate through our integer array of cards. So let's start writing the function. Basically, we wrote the entire the pseudocode down here, and now we just need to transcribe that into our program. So let's get started. So the first thing we'll need to do is we want to set the high card to the first card in the hand. So we want to set an integer value called high card, which we will eventually return. And high card at the beginning of this function will equal the first card in the hand. So the 0th element of our card array. Okay, now the next thing we're going to want to do is it says let's iterate through our hand. And so after this comment, we will write a for loop that will start at the index of 0, and then it will the test condition will be while the index is larger than num cards, which is a constant integer storing the size of our card array. And then we want to update I. Just our classic for loop looking through the size of an array. And then what we wanted to do is we wanted to test to see if, if the card that we're looking at is larger than the high card marker. So if current index is larger than high card, we want to update high card. So that's the case where, for example, 6, the current index is larger than what we set high card to originally of 4. So we're going to update high card to equal 6. And then we do the same thing when we get to 9. We, instead of high card being 6, we update it to equal 9. So this line of the pseudocode. So we want to update high card, and we're going to set high card to equal cards at the index we are at, just like this. And so by the end of this for loop, once we iterate through everything, we will have the highest card in the hand and we'll return high card at the end of this function. So high card, this is a unique function in PokerHand because it's not going to return a true or false. It's going to tell us actually what the number of the highest value was in the integer array. So that's why we have an int high card, whereas every other function returns a Boolean, a true or false. Okay, so let's move on to our pair function. So what does a pair function do? It's a little bit more challenging to understand than the high card because what we need to do for a pair is we need to compare each card, each element of the integer array. So for example, we'll start at number 4. We need to compare 4 against 2. We need to compare 4 against the number 6. We need to compare 4 against the number 4. We need to compare 4 against 5. And then we also need to do the same thing for every other element in the card array. We need to compare 2 against 6, because we haven't done that comparison yet. We need to compare 2 against 4, 2 against 5. So this will require using 2 for loops. So you can see, for example, we have some notes here, but we're going to have 2 for loops like this form. So the outer for loop will compare each element in the array, whereas the inner for loop will compare the next element. It will start at the next element in the array. So, for example, if the inner for loop, the I for loop, starts at 7, the inner for loop will start at I plus 1, which will be this number 8. And then, so it'll compare 7 against 8, and then the inner for loop will update until it reaches the end of the card array. So the first comparison will be 7 against every other number in the card array. So we compare 7 against 8, 7 against 2, 7 against 4, 7 against 7. And then we update the outer for loop. So now we're looking at number 8, and then the inner for loop starts again. So it looks at I plus 1. So if we're now looking at the index of 1 in the outer for loop, the inner for loop will look at I plus 1 and start at the next element where I equals 2. The index is 2. And then it'll look 8 against 2, 8 against 4, 8 against 7. And then the outer for loop updates again, and now we're looking at the number 2, and then the inner for loop, J, will look at the next element. So it will compare 2 against 4, then 2 against 7, and then the outer for loop updates again. Now we're looking at 4, and then we only have one comparison because J will equal I plus 1. So we're now looking at the 4th index of the num card array, and we just compare 4 against 7. So basically, what the entire function will do is it will compare every card against each other. And what we'll do is, so we have outer for loop that starts at the index of 0, and then the inner for loop that starts at I plus 1. And this is the comparison for loop. And basically what we'll want to do is, if we will have a matching pair of cards, if the card at element I is equal to the card array at element J, this inner for loop that's comparing the next cards in the array and iterates to the end. So if this if statement is ever true, that means we have found a matching pair of cards, and we'll want to return true. If we look through every element in the card array and compare it to every other card element in the array, and we do not find a condition where the current card that we're looking at is equal to a comparison card, by the end of these two for loops, and if we haven't found this condition, it means that we do not have a pair. And once we are done with both of those for loops, we will return false. All right, so hopefully that was not too confusing and verbose. Let's take this code that we have right here and let's transcribe it into our PokerHand.cpp file. So we're going to use a similar for loop at the beginning because we're going to iterate through the hand, basically the card integer array. And I'm going to use variables that are different than I and j, just so it seems a little bit conceptually clearer. So instead of using int I am going to make a new variable that's going to be called cards index, and that will be equal to 0. And so we're essentially just replacing I with something called card index, so it's just a little bit clearer. And we will iterate until card index is less than num cards, and we will want to update card index by 1. Great. And now we'll need to have an inner for loop. So we want to compare each card against the others against the remaining cards in the array. And we'll do that by writing a nested for loop. So the one thing that's important to understand is that a nested for loop, so a for loop inside of an outer for loop, this one will iterate until the end of its test condition before the outer for loop updates its variable. So let's write, so this is the j loop essentially. We want to initialize a counter variable for this nested inner for loop, and we'll call this comparison index. And we'll start it at, we want to initialize it so it's comparing the next card relative to the outer for loop that starts at cards index. So we're going to want to start it at cards index plus 1, and then we want the comparison index to iterate until it is the size of num cards, and then we'll update comparison index by 1 each time. Great, so this is the structure of the nested for loops that we're going to be using, and we'll be using this structure of nested for loops throughout the remaining functions in this assignment. So let's look back again at the pseudocode that we had written. So here is our outer for loop, the I loop, and then the inner for loop, which we initialize to be the outer for loops variable plus 1. All right, and then the next thing we want to do is we want to see if we ever have a situation where the card that we are at in the outer for loop, for example, let's say, let's go to this example at the beginning. So let's say our I variable is initialized to 0. So this is the very beginning. So our outer for loop is looking at the number 4. And what the inner for loop will do, the comparison for loop, is it will look at I plus 1. So it'll look at the first index. So we're comparing 4 against 2. Those do not equal each other. So then the nested for loop, the inner for loop, the comparison for loop, will now iterate to the number 6. Are 4 and 6 equal to each other? No. So then the inner for loop will iterate again, and now it's comparing 4 and 4. And here we have a match. So the conditional statement we want to write is if the outer for loop index is ever equal to an element in the inner for loop index. So in the code that we are writing, we're going to want to see if an element at cards index is equal to an element at the comparison index. So we'll write an if statement that says if the card array at the cards index is ever equal to cards at the comparison index, then we will return true. This will indicate a matching pair. And if we finish both of the for loops, we basically have compared every single card against another card in the array, and we didn't find a condition where this was true, where two cards were equal to each other, then we'll know there were no matching cards and we can return false. Great. So that's basically the structure of the pair function, where you're going to want to use a for loop and then a nested for loop that it's a comparison for loop. It will look at every other element in the card array and compare it to whatever number we're looking at in the outer for loop. So now we're going to move on to two pair. So what is unique about a two pair? Essentially, we're going to use we're going to use similar code to the pair function. But what we need to do is we need to keep a counting variable to see how many times we find a matching pair of cards. So what we're going to do is we're essentially going to copy the code from the a pair function, but we want to make sure that we can find two pairs. So for example, a 4 and a 4, and then a 2 and a 2. So what we can do is let's just copy and paste the pair function into two pair function, and then we'll see what kinds of changes we need to make in order to keep count of how many pairs there are. So let's take basically everything above this return false statement, and then we will replace it into the two pair function. So we iterate through the hand, and then we're going to use a nested for loop to compare the card index against every other card that's in the card array. So this is when this if statement is true, this is when we find a matching pair. So since we are using the two pair function, we want to find two unique numbers, for example, a 4 and a 4 and a 2 and a 2, that are both pairs. So instead of just returning true here when we find a single matching pair, instead we're going to need to keep track of how many times we enter this if statement. Basically, how many times we find a matching pair. We don't want to return true because this will end this function the first time we find a pair, when in fact we want to count and make sure that we have two matching pairs. So what we'll do is we're going to create a counter variable at the beginning of our function And this will keep track of how many times we have a matching pair. So I'm going to declare an integer variable, and it's going to be called matching cards. And this will be equal, we'll set it equal to 0 at the beginning of our function. And what we want to do now is when we find a matching pair, we will increase matching cards by 1. So we'll, using this plus plus, this will basically just increase matching cards by 1. So if we find 2 matching pairs, matching cards, so the first time we find matching cards, we add 1 to the value of 0. So when we have 1 pair, matching cards will equal 1. And then when we find our second pair, matching cards will iterate from 1 to 2. So basically, when we're done comparing every card against another card in the card array, if we have a 2 pair, this matching card variable should be equal to 2. So you can see at this comment, we want to check to see if the counter variable matching cards is equal to 2. In that case, we will return true. And if matching cards is any other value besides 2, we'll return false. So we want to check to see if matching cards is equal to 2, and then we'll return true. If it's equal to any other value, we'll want to return false. Great. So now let's see, we have 3 of a kind and 4 of a kind, straight and full house left. So I'm going to pause the video for now, and I'll return with a part 3 that'll cover the rest of the functions. Just make sure, if you feel confused, try reading through some of the notes that are in the handout. And you can also rewatch parts of this video. Anyway, stay tuned for part 3, which will go over the remaining functions: 3 of a kind, 4 of a kind, full house, and straight. Thanks for watching.